Hello everybody, thank you so much for joining us for today's London Java Community Round Table event. My goodness, sponsored by Pyara. As you can see, I am proudly wearing my Pyara t-shirt today. I'm very excited to welcome you all here. For those of you who don't know me, let me introduce myself. My name is Abby. I work with the LJC and the other 15-ish communities, all of which are free for our members and run by RecWorks. RecWorks are a tech recruitment company with a huge difference. So obviously as a company, we're always on the lookout for more clients, and some of our best clients have come from community members who recommended RecWorks to their internal talent team. So if you're hiring for a new team or you're working for a company that is, please do let us know. If you want to know more about what we can offer, just ping me a message on LinkedIn or Slack. My name is, as you see it on the screen, and we really look forward to working with you. So what's the difference, I hear you ask? Well, also, we really do believe that recruitment can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development, and that is where our communities and events come into play. If people want to learn and others want to teach or share their knowledge, we are more than happy to connect you through our communities and events. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. To date, we have run hundreds of events for engineers and developers, students, graduates, CTOs. We have run conferences, lightning talks, hackathons, all sorts. Earlier this year, we actually made our 5,000th introduction through our Meet a Mentor community. We're really excited about that and looking forward to making even more connections there. As I've said, we love to give opportunities for people to connect, and this event is part of that as well. If you would like to know more about any of our other communities, please do, again, get in touch with myself or Helen Lewis if you know her, and we can take it from there. Our panel today is made up of Steve, David, Mary and Rudy. I am just going to give them a couple of moments to introduce themselves in just a moment. And to let you know, the recording of today's session will be available on YouTube. I will put the link to our channel in the chat for you so you can access it when it's ready. If you do have any questions throughout the event, please do raise your hand so you can unmute to ask, or put them in the chat. This is intended to be an interactive session. So I do have a list of questions to go through and for our panel to answer. But if you think of anything, please do let me know, and I'm more than happy to let you chip in and see where the conversation goes. That's absolutely fine. So like I said, our panel, I'll start off with Steve, if you'd like just to tell us a bit about yourself.
Yeah, thanks. So I'm Steve Millage. I'm the founder of Pyara. Pyara is a software company, and we ship Jakarta EE microprofile compliant runtimes ranging from Pyara Cloud, which is a platform as a service, through Pyara Server, traditional app server, and Pyara Micro, which is focused on containers, microservice deployments. We're founding members of Jakarta EE Eclipse and the microprofile working group as well.
Fantastic, thank you. And David?
Sure. My name is David Heppelfinger. I'm an independent consultant based close to Washington, D.C. I've been working with Java and related technologies for more years than I care to admit. And I've written a number of books as well. The most recent is actually a book on Pyara Micro and Microprofile. So if you're interested, check it out.
Thank you. And Mary?
Sure. Yeah. So I'm Mary Grigleski. I am based in Chicago, and I am a streaming developer advocate currently at DataStax, company that actually supports open source software, Apache Cassandra, Apache Pulsar, and that's what I'm working on now, Pulsar, as well as now getting into real-time AI. And I've been developer advocate for the past 5 years or so. I was with IBM previously, and then I'm also a Java champion and also the president of the Chicago Java Users Group.
Fantastic, thank you.
Thank you.
Rudy?
Yeah, thank you. Yeah, I'm Rudy de Busser. I'm living in Belgium. So we have all kind of representatives in the world in our panel. I'm working with Java and Java EE and now Jakarta EE for about 15 years. Also a very long time. done some development, coaching, training. I was on the vendor side, so I was also on that side. And I'm trying to help the developers getting whatever they need.
Excellent, thank you. So as you can see, everybody, we have a great panel for our event today that's talking about microservices. And so we've got some questions, as I said, to go through, but if you do have any questions during the event, please do ask them. We're more than happy to have some discussion. So the first question I've got here, feel free to chip in, any of you. What are the benefits of microservices? When is that a better choice than some of the alternatives out there?
Shall I go first then? I shall commit myself first. One of the biggest benefits is not technological, really. It is about, and this is the one I'll talk about, others can talk about other different ones. It's about organization. So one of the benefits of microservices, obviously, is decoupling different components in a software architecture. And that has a benefit from an organizational structure, is that you can decouple teams that are working on small pieces of architecture or functionality for the business. So if you have multiple microservices, you can have like an independent team working on each one. So you can have one team working on one microservice, another team on another microservice. And as long as they have well-defined interfaces, well-defined dependencies, then those teams can work somewhat independently, and also they can work somewhat on different technologies if that's something you want to do as an organization. There's another question about the burden of supporting multiple technologies within a single organization, but it is possible to build microservices, different technologies, because typically in this day and age, the interface is going to be through some technology independent protocol, some REST or some messaging or something like that.
One of the things that I like is that the code bases tend to be smaller. When you are developing a monolithic application over the years, I mean, the number of lines of code gets out of control and it's very hard to understand. So when you decouple and develop your application as a series of microservices, the code bases tend to be a lot smaller and a lot easier to understand. So I have to throw that out there.
Yep. I think I'd like to also basically agree, right, with what David already talked about, is the decoupling nature. I think that's what is like most attractive. I mean, I kind of liken this to using microservices architecture is like you have each independently managing itself. So, and not to say there are disadvantages, but the advantage is that you each can manage on its own. So you don't depend on one another. So it enables, especially too, if you're going into an asynchronous style of communication, is really ideal, like way of, implementing this type of architecture and then using async way of communicating. But barring other disadvantages, there are disadvantages too, but let's talk about the good stuff. But definitely the decoupling is what is very attractive, I think, so.
Yeah, and with that decoupling, then I think also comes that you can scale it independently, because if you have a larger application, not every part is used as much as the other part. So if you have a certain functionality that is used a lot, your server cannot handle it anymore today, then you can scale that up independently from all the rest, because it's no longer coupled in one big deployment. So that's also one of the benefits of microservices, of course.
Excellent, thank you. So Steve, I think already mentioned there are some challenges and common pitfalls of microservice use as well. Can you tell us a little bit about what that might look like?
Me, okay. Well, we've all talked about decoupling. So one of the pitfalls is decoupling in some extent. First, decoupling is hard. So if you don't decouple well, then and you build dependencies and you have decoupled services that have complex dependencies between each other, lifecycle dependencies, you know, call chains and everything. What you've gone from is like what was a monolith or an architecture where things were sort of tightly co-located, tightly deployed together, to a whole bunch of coupled services that are distributed all through your architecture, distributed through your data center with distributed calls, and then you hit all the disadvantages of a distributed system without any of the advantages of the microservices. So getting decoupling right is the key bit, and if you don't, then you're into basically a world of pain.
Yeah. And one of the things that Steve mentioned earlier was, you know, this architecture works fine if you have well-defined interfaces. The problem is you don't always have them, and sometimes you have to change, for example, the JSON schema in a microservice, and by doing that, you could potentially break other microservices that are calling yours. You know, so how do we handle this kind of thing? And I actually ran into this type of situation in a project I was working previously, pretty big project, and what we ended up doing was, if there was a breaking change like that, instead of removing the old version of the microservice and replacing it with a new one, we will keep both of them in parallel. That way, whoever depends on the microservice doesn't break immediately. And then we will coordinate among teams. You need to update your call to our microservice because the old one is going away, instead of yanking them, you know, without warning, if you will. So that's one of the disadvantages that may have. If your interfaces changes, you could potentially break, you know, other functionality in the system.
Yeah, and my thinking is that I think, you know, it's just like anything else. Once you have, you know, smaller units kind of operating, then obviously too, you introduce more opportunities for hackers to come in. So in other words, like security would be a big concern too when you're working with microservices, especially because you have each one of them independent. You are exposing more, like, so to speak, like an external like interface to the outside world. So it's also introduced more opportunities for hackers to come in. I mean, there are always creative hackers out there, and they will think of ways to come in and bother, you know, kind of disrupt your whole piece of your whole ecosystem. So security will be a big concern too, and it's harder to do for microservices, you know, environments. So yeah.
Mm-hmm. Yeah, and maybe I'm going to talk about, okay, an obvious other downside is that it's probably slower because you have the network overhead at a distributed nature. But I want to talk about something else, which is maybe a downside, which I experience here in a large bank, is that not every kind of functionality can extract it in microservices. Also, it might be a good idea at first, because what they did was they had a microservice which provided the labels for their application on the website and even on the ATM machines in the different languages. And that sounds a good idea because you have one single place where you can manage all those things, but at one day that service was down. So the entire website and also the ATM machines were completely unusable because there were only those cryptic keys for the labels which were on the screen, and yeah, it was all over the place, and you could not do anything anymore unless you knew what each button exactly did. So splitting up in a microservice, you need to think about, is this really something which is possible as a standalone function? What happens if it does not work, etc., etc. So you have to think much more about how you're going to solve some of your use cases and your user scenarios in your applications when you're using microservices.
Just to pick up on something Mary said, very specific point. She's talking about security and hackers. Obviously, if you're distributed, then you, in theory, you can't trust the caller. So in that situation, you also then to revalidate all the inputs you get. You can't, in the same way as you can't trust a browser, then, in a microservices world, you may not be able to trust the caller. So you could be duplicating huge amounts of data validation logic, never mind any of the data security sort of implications.
Okay, so obviously, just because you've mentioned this already a couple of times, what are some other security considerations you should maybe have in mind then if you're looking to adopt microservices? Like, obviously, you've mentioned a couple. Are there any other things we need to sort of be aware of on the security side of things?
I said one, so I'll let others go first. I have others, but
I mean, one thing you could do, you don't necessarily have to have all your microservices exposed to the world, right? You could have some of them, whatever's internal, behind a firewall, or either a cloud provider on premises and what have you, and just whatever needs to be exposed to the world, just expose that. That way you limit your surface area, right? The potential of attacks for your system.
And one of the common things for security microservices is that what Steve mentioned, you need to validate the caller, etc., is that you propagate that information through a JOT token, so that you have assigned information about who is calling, what are his roles, what are the permissions of the caller. You put that in a token signed in the header of the call, so that's that can be verified quite easily without the need to look up that information or validate that information on another service, because that again can cause some bottlenecks, some performance issue if you have one single point, one single failure there. And yeah, that's a common thing for addressing those security issues.
Wonderful, thank you so much. I'm learning so much already today, and we're only a few minutes in. This is excellent. I'm looking forward to seeing what else I can learn today. So thank you. So then, how can microservices be designed and tested and deployed effectively in this cloud native era? What are the best ways to go about that?
Yeah, so I think there are a lot of people that start saying this more and more, that you should not start your project by thinking, oh, I need microservices. Most of the time, you should start with maybe just a monolith, make it then modular so that it can be split up easily afterwards. But don't start it as an idea, oh, I need 100 microservices all independently with a large scale infrastructure, because most of the time, if not all the time, it starts small, the usage of your application. As we mentioned, one of the major benefits of microservices is that you can scale it. But what if you have only 10 or 15 users? What's then the benefit of having a large scale environment with a lot of microservices? Then the drawbacks are way much worse than the benefits that you have. So first of all, design your application that it is modular so that it can split up, but don't start as a full-blown microservice environment.
Yeah, I think that's a good thing. And as you're designed for modular, and designing from being modular or decoupled, it also enables you to test a lot easier. So if we're working on, as David said, versioned interfaces, with well-defined constraints, then you are able, from a testing perspective, to more easily test a microservice standalone with some mocked services. Because what you don't want to do from a unit test perspective is have to stand up a whole suite of microservices to run some functional tests on a single service. So again, we're back into decoupling and then using technologies which I know Rudy likes, such as test containers, and being able to mock out some services in test containers so that we can stand up a small subset of our system for testing. Because let's say you really don't want to have to stand up a full distributed architecture to run some unit tests.
By the way, I have a presentation on that next week at the DevNexus, and I'm just doing it also online with the Eclipse Foundation. So around that testing. But
I set it up for you there.
yeah, I could not leave that, of course.
No, it's always good to do a plug. Absolutely. Sorry, Mary, did you want to add something?
Oh, I was going to say, yeah, Steve and Rudy put it, very well put together answer, right? In terms of deployment and testing and all of these, that is like benefits of using microservices, because it's all decoupled is easier when you want to only test certain parts of your system and you focus on that part, and they are all already independently managed. So you should be able to do that easily and from a deployment perspective too. So I can't agree more on that. Yeah, just kind of like emphasizing that aspect of it. So yeah. So
wonderful, thank you. So we've actually had a question come up in the chat here. Let me just grab it up. Sorry, my window's very small. There we go. So how do you handle the cognitive load of microservices? The question's coming because he says, I used to be a Java developer. Now a lot of my efforts are figuring out Terraform, Helm charts, security, DDD implications, pipelines, etc. So now there are many things on top of writing code. So how do you handle the cognitive load of the microservices?
Okay,
yeah, that's a very good question, right? And it's absolutely true. I mean, we as software developers, we used to worry mostly about code, and all the infrastructure and security and all that stuff was handled mostly by operations or system administrators and what have you. But now, the most common way to divide a team is through DevOps. So now developers have to worry about operations as well. I don't think there's an easy answer to that question, but in general, usually at the beginning of the project, there's some, practices put in place, and once that's established, it's kind of becomes second nature or is automated or what have you. It's more of a concern at the beginning of the project, but I can't really give you a specific answer to what you're asking. It's just an issue in general.
I'll pick up, and again, it's not a specific answer, but I was basically going to say, to be honest, it's up to vendors like Payara to solve this for you as a developer. In Kubernetes, let's be honest, we're in an early stage of the technology. It is, in my opinion, a really bad application server, in the sense bad because it's exposing a huge range of complexity to you as an individual, as a developer, which is not necessary. I mean, Helm charts, Terraform, it's about deployment. It's, and we solved this problem back in the past through runtimes. And I know application servers get a bad name, but this is actually what they did. And there's a move at the moment into something that is trendy called platform engineering, which again is going back to, everything goes in cycles in IT. It's going back to the view that you have an platform engineering team that builds you a deployment platform, and then as an application developer, you package up that application into a deployable unit, in this case, a Docker container or container, and the platform will manage that for you. And I think this cognitive load will slowly go away. So we've shown how that works in one of our latest products called Payara Cloud, which basically for Jakarta EE developers, you just take it, package up what was a WAR file, and the Payara Cloud runtime manages Terraform, Helm charts, security, pod definitions, YAML, and all that sort of thing. And that's not going to be a unique product longer term. These things will be abstracted away because there's huge benefits in actually automating and abstracting these away from developers. Huge productivity benefits.
Yeah, I think, as mentioned, there is now a lot of DevOps, and the term is mentioned that the DevOps, or the developers, only need to do operation. That can be a good thing, but maybe it is too much for some people, that they cannot handle all those things, or they are not sufficient knowledge knowledgeable about all the things, all the details, because Java is one thing, that's just one language, but now there comes easily 5 things on top of it that you need to learn before you can deploy it. So probably in smaller teams, yeah, you have the DevOps people need to learn way much more than before. In larger organizations, like also Steve mentioned, you have more or less still a team that is tasked with getting it up and running, and the rest keeps on developing as before. So, but yeah, most of our companies, most of the teams are smaller. So as the person that mentioned the question, yeah, you need to learn a lot more now these days. True. And I guess maybe it's a bit soft if you go to a big team, but yeah, that's not always the idea of some people, or of course.
Yeah, if I may ask too, although, you know, it's not about advertising my company's project, but the thing is, I actually work with open source project is Apache Pulsar. So it's an event streaming platform that's kind of, you know, if I kind of put a comparison, if you're not familiar, that would be Kafka. Just like Kafka, and a lot of companies these days are also doing messaging. So, and I think Steve brought up a real good point, is the fact that, you know, a lot of times to this aspect of, you know, cognitive load of microservices or any system will probably, you know, be all of these focus of all of these infrastructural concern that's kind of outside of just doing development should actually be on, you know, the burden should be on the vendor, on a platform type of implementation. So I want to bring up is that, say, for example, Apache Pulsar is really infrastructural aware kind of system that, you know, for example, you have, you know, we're talking about messaging, then there are message brokers. Brokers can be scattered on different nodes and things like that. So Pulsar itself already is built in, so it knows if you add a node to an infrastructure, add a server, all of these brokers needs to be rebalanced. So this is something that Apache Pulsar is capable of doing as an event streaming type of platform. So probably too, like Steve also talked about, you know, is eventually maybe all of these concerns will go away. And I think, you know, for example, like Apache Pulsar would be like one platform that's already taking care of this kind of concern. So I think, you know, it's just poised to become like really cloud native ready, infrastructural ready type of system that will take away the burden from the developers to worry so much about these extra thing that takes you away from focusing on your business algorithms, right? Things like that. So yeah, I think for sure, I think on the platform level, that should be the way to go. You want to look for systems that can help you that you know, with that type of concern. So.
Okay, so I think you have kind of answered my next question already, which was about whether microservices can help optimize the DevOps side of things. Has anybody got anything further to add on that sort of perspective?
I'm going to go ahead and say probably not. You know, when doing microservices, we as developers, like the person who asked the question said, we have a lot more responsibility than just the code. You know, there's a lot of infrastructure and stuff. There are tools that help, like Steve mentioned, Payara Cloud. I've actually tried it and it's really nice. And you know, the tool that Mary was talking about. But if we don't have access to these tools, you know, there's still a lot of operations tasks that we had to do that wouldn't be there if we were working on a more monolithic traditional application. So unfortunately not. That will be my take. Yeah.
Yeah, I think microservices put an extra layer of complexity and difficulty on top of what we already have. So it's not operational friendly now.
No, I agree. I think, I mean, DevOps originally came out because developers were frustrated at the speed it took to deploy things into operations. I think what Microservice is doing is flipping it the other way around and actually frustrating developers into how much operations they now have to do, and it's not actually necessarily speeding it up. I mean, and there are advantages from a monitoring and perspective like that. You know, you can take down services individually. You can do you know, blue-green deployments and rolling upgrades and things in a microservices architecture, probably simpler than well, maybe not simpler than a monolith, because a monolith you would take the whole lot down in one go. But there are smaller things that you can do, smaller components of your architecture you can upgrade and manage rather than take the whole lot down. I think from ops, there's probably some optimization, but I'm not sure from DevOps.
Sorry, having a slight issue with my mic there. There we go. I've got it back on. We're all good. So if you decide you want to start using microservices, then how would you decide on the appropriate size of your microservice? What sort of factors go into that decision?
I'll kick off. So that's the one to start the war, I think, now in your organization. And that has been the case ever since component development started, ever. What is the right size for a microservice is the same argument as what was the right size for a component or for a SOA service or everything that came before. I have some views of it, and I think they come back down to what we've learned, many years ago in component development and modular architecture. It's about getting a balance between consistency and coherence of some functionality around. I always thought of it as a piece of around some sort of data that it manages or masters. So if you can put a boundary, like a domain, around a piece of data or a piece of functionality, and you can give it a well-defined interface, which can be versioned, and so therefore, decoupled, and you don't have data dependencies across to other components, which comes into sort of questions on data consistency. And you can define, what events it subscribes to or what events it emits. Then you've got a candidate for a microservice, and then you can argue about whether it's too big or too small, or whether it's in the infrastructure layer or the functional layer. And you can start the war on that basis. I think the amount of meetings I've had in my career on whiteboards of how big should a service be, whether it's an infrastructure service or whether it's a business service. And then the final war of what to actually call it is the hardest problem in software engineering, I would say.
Yeah, I think in that sense, the term microservice is wrong because it's not. It should not be as small as possible. Because micro suggests that it should be small, but that's not the case. It's more like what Steve says. We should call it a bounded service or whatever. That you should group some functionality together, which plays nicely together, which uses the same data sets, etc. And that can be as big as a monolith if needed. So it's really difficult to say what is the right size.
Yeah, I agree with Rudy. There's no one answer that we can give that applies across the board. But in general, I mean, it's how to divide your application, how to structure it. So, instead of having, let's say, a microservice that handles data for any business or whatever, I wouldn't do it that way, but have microservice for a specific business use case, right? Have different microservices for each use case. And depending on the complexity of the use case and the specific requirements, that will determine the size. Just keep it as small as possible, but not so small that you cannot, handle the complete use case in one service. That would be, how we'll go about it.
Yeah, and again, I can't agree more with what Steve, Rudy, and David have said. It's like the answers is really, it depends, I think. Depends on your specific use cases, your ecosystem. You basically, I think if we need to understand the business context and then determine what would be best to solve the problem at hand. And then, you design, maybe microservices, the name is really misleading too. It shouldn't be called microservices, just call it some kind of service. And they should be, maybe it's like the characteristic should be asynchronous or like independently manageable or very easily deploying, easily maintained. Maybe that should be the guidelines. And then these are just independent services that they need to be interacting in a very coherent fashion, even though they may be operating independently. I think that's what my thinking should be. Maybe the term is just really misleading, I think, so.
Yeah, I think fundamentally, all engineering is trade-offs, and, you need to trade off speed, performance. You wouldn't want a microservice where you make 500 remote calls to render a page. So I hope in that banking example, they didn't actually make a call for every label. That would be really bad. And then, so, and it's a trade-off between size versus coupling, network overheads, resilience overheads, how you handle failover. So all engineering, I think, is trade-off. So it's basically it's a Goldilocks thing, isn't it? It's like not too hot, not too cold. So not just right. It needs to be just right in size. And how you get that just right, I think, is a engineering decision, architectural decision.
And also an art too, even though we think we're doing technical stuff, it's actually an art.
The other thing to watch is, I mentioned at the beginning, that's one of the benefits of microservices is it allows organizations to develop independently. The problem you have then, though, is that you end up risking that your enterprise architecture is just a reflection of your organizational structure, as opposed to what is the best engineering architecture. So you may that, basically you have this architecture because you have those teams, and it probably shouldn't be that way around. But there's always a danger in larger organizations that it becomes that way around.
Okay, we've had another question come up in the chat, so I'm going to throw this one out there for you as well. Would you say that Kubernetes is the go-to for container orchestration?
I go first again. For container orchestration, I would say yes. But that depends on whether you can manage the overhead of managing Kubernetes. So if you're on clouds, then it's quite easy because you can just spin it up, quite quickly. But I would say for container orchestration, yes. I mean, there are cloud-specific alternatives like Fargate and things. So if you're on those clouds, and then you could take a look at those, and they may be a lot simpler than Kubernetes.
I would say yes to the question, but the reason is because you don't have much of a choice, right? Pretty much everybody uses Kubernetes, so it's either that or, I mean, there might be others. There's tools that build on top of Kubernetes, but right now that's pretty much it for the most part. Wherever you go, they're going to be using Kubernetes.
Yeah, there were a few alternatives like 5 years ago, and they all went away in favor for handling the environments based on Kubernetes. So there are still some alternatives, but it's a minority of the products and environments that use something else. So it's not a standard, but it's the de facto standard, which probably 90% of the world uses. So
I think a follow-on question is, should you use Kubernetes at all? I mean, that's a different question because you won't necessarily need Kubernetes if you're using containers, because there are other alternatives and simpler alternatives. And there's a reason that it's popular in the cloud and managed services for Kubernetes, is it is a very difficult thing to set up and manage from scratch. And I think that, let's say, I think, as I mentioned in my previous answers, I think it will go away in the sense that it'll go away as something a developer needs to know. Not that it'll go away as underlying infrastructure or underlying architecture. But at the end of the day, it's a compute platform, and developers typically don't need to manage compute platforms. Developers don't typically manage servers and VMs and networks and things like that. And fundamentally, that's what Kubernetes is. So I think it'll go away largely as a developer concern long term or medium term.
Actually, Steve, you reminded me too of, like, when you talk about like this, this is like Kubernetes is the talk of the town these days. I mean, in today's computing, but what it used to be, right? Like in let's say 90s, it was Linux coming out, you know, should it be Linux or Windows? And now that whole thing is gone too. So I think it's likewise, maybe it's just in the timeline of things, probably like Kubernetes or any platform, you know, eventually will be like less of a big concern, because then maybe we'll move on to ChatGPT, maybe, or something, right? It's the next wave of discussion.
Yeah,
so.
like before that, it was VMware, vSphere. Everyone needs to know VMware, vSphere, and no one knows to know it now. But vast majority of stuff, a lot of things will still be running on there. They're just not a developer concern anymore. So because it's been abstracted away.
Sure, yeah.
I was purposely avoiding bringing up ChatGPT, so thank you. That's a whole minefield of its own, I think, and probably a topic for another time.
Very true.
So how then, you've assumed for a moment you've decided to go with doing microservices, you've decided that's the way that you need to operate. So how do you ensure then that your microservices, assuming you have multiple ones, how do you ensure they can communicate effectively with each other in your distributed system? Like what are some of the best ways to be able to look at that and ensure that that works well?
I mean, at their core, microservices are just RESTful web services, right? So if your network infrastructure is fine, your servers are up, you know, there's no concern. The issues is, what if the network is a little flaky, a server is down, or, you know, something like that happens. So then you can run into issues that you wouldn't necessarily have with a monolithic application, because in that case, there wouldn't be as much network traffic. There's a number of things that we can do to mitigate this. I mean, there's design patterns. That one is very popular, circuit breaker. So essentially, circuit breaker, a microprofile has an implementation that we can just use. If you start calling a server and it starts failing, you get, you know, an error back or an exception or what have you. If it happens a few times, you know, in sequence, then you can just automatically stop calling that method. Every time an attempt to, you know, call it happens, you actually don't. With microprofile, you will get an exception called circuit open exception or something like that. And then after a few tries, you can half open the circuit and try to see if the service is back up. And if it is, then you can start calling again. Otherwise, you stop calling again. You know, so there's things that automate. There's APIs and things that help make all of this more reliable, this network communication.
Yeah, another thing what I want to mention here is that because you're distributed, if service A wants to call service B, it needs to know where service B is. So a lot of people say, oh yeah, I can use a service registry for that. You look up the name and then you know where it is. But basically for me, that's an overhead. Because if you just set up your environment like service B is located at a virtual host called service B, then it is up to the network, the load balancer, the network services within Kubernetes or whatever, to know where it is. And then you have already one level of complexity less in your system. You have one down, and it works just as fine. So I think that is a improvement. What I always mention, people say, oh, no, I need something like Zookeeper or whatever. And I say, no, you don't need it. That's also for that cognitive load of that developer. He needs to learn one system less. So that's also a way of keeping the communication between these services efficient.
Yeah, and I think because you're in a distributed system. So if you're going to make synchronous calls, then you need to know and handle failures way more than you would in a non-distributed system with microservices. So you've got to worry about, you know, which calls are repeatable, which calls you could call, you know, through idempotency, and whether there's a, you know, change or whether you can fail over. So David mentioned circuit breaker. I mean, circuit breaker effectively tries to sort of resolve some resource constraints and solve, you know, threads hanging for a long time. But fundamentally, it just pushes the error back to the caller and says, you know, you deal with this, I'm dead. And you have to be able to deal with that. Obviously, just there's alternatives. I mean, you can, from synchronous calls, you can move into event-based architectures and event architectures through setting up Mary here around, you know, messaging, using messaging instead, and go async. Now, async is fantastic, you know, for scalability and decoupling, but then that does go back into cognitive load, sometimes put a large cognitive load on people trying to understand how the system works. From, you know, humans are good at thinking, oh, if I do this, this happens. Not so good about coping with, you know, various coordinations of events that are occurring asynchronously in our minds. So go async is another way.
Yeah, Steve, you just read my mind. Yeah, and in fact, you know, I was gonna say, yeah, also you can consider, right, doing things in the messaging, asynchronous messaging way, and making use of a broker, right, such as like, you know, Kafka or Pulsar. They are pub/sub broker, and so in some ways too, then there's no need to worry about address, right? Your event-driven type of messaging is basically, you know, your producer produces messages, you just send it to the broker, and basically broker will deliver the messages. So from a client, you know, consumer perspective, you just need to subscribe to those messages, then you receive them. And the advantage of such too is that you can also send messages in bulk, and it's very scalable, very elastic, and also resiliency aspect usually is good too, because you have brokers that are running. If one broker goes down, the other, you know, the platform should take care of spinning up another broker, things like that. So there's also advantages of using like a synchronous messaging broker to handle communication between microservices. Now, Steve also brought up the fact is that it also opens up another can of worms. And what do you deal with? You know, tracing, right? And how do you dealing with debugging, things like that. So yes, there will be another level of complexity, but it also helps you, you know, on the other side, you know, of like asynchronous, and just easier in that sense. So I think, in other words, there's nothing, you know, complexity never goes away. It just kind of moves around to different layers depending on how you do things. So yes, this is very interesting. I mean, if you think of it positively, it's an interesting problem to solve every day. It keeps our life busy and entertaining, if you can look at it that way. So yeah.
Yeah, and I agree that asynchronous is in many cases a solution. You need to probably call multiple services, and if you do that synchronously, yeah, then you lose a lot of time just waiting before the calls come back. But don't use asynchronous because you can do it, because some user scenarios, they don't work together with asynchronous response times. I had that one project where they came to me saying, "Oh, yeah, but when the user enters in the screens and goes to the next screens, he still sees the old values." Yeah, because the asynchronous pipeline was still processing your request. So they just asked me then, "Oh, can you not just put something that waits until the page go to the next screen until everything is done already?" So yeah, make sure that you use asynchronously wisely, and then of course it can play out very well. I agree with that.
Yeah, I think it's a key point you got, really, which is, you know, don't let your architectural decisions expose them to your users. You know, a user does not want eventual consistency. You know, it might be a perfectly good architectural solution to get scalability, but if they refresh their page and the date is different than when they just entered, then they're not happy. I mean, I've got a very old, long time ago, I did something on a sports event, and they used eventual consistency. And when a when a user was refreshing the page to see who was winning, it would actually jump around because of eventual consistency, or who was leading the pack. It's just not a good, you know, solution for a user perspective. So so things like eventual consistency, and then again synchronous. You know, if someone needs an ID, they need an ID, and they need it now, and they don't need to wait for it, because a user doesn't want to see something refreshing in the background or pop up or something. So whatever we do, you know, we should be careful not to expose that into the user layer.
I've had another question come through in the chat. Is there a difference between async and reactive?
Okay, so I'd like to take this because I actually had a talk on something like that, right? Reactive. So I also advocated, I guess, on reactive systems. So reactive is a bit more like if that's what you're referring to, reactive, there's some subtle differences between the programming and reactive systems. So very often, if we talk about reactive systems, we're referring to the reactive manifesto, like based on those principles, right? Scalability, elasticity of your system's resiliency, and also message driven. So that's more of a, to me, right? It's kind of, I've thought about it, it's more of a abstract way of describing what your system should be, a little bit on an abstract level. Whereas like, I think asynchronous is a bit more down to earth, so to speak, right? It's a mechanical aspect of we're doing asynchronous style of processing, of messaging, things like that. So I think I would look at it from that kind of perspective. And anytime, if it's reactive systems, it's very often is making use of these asynchronous way of mechanism of doing messaging in between. So that's how I kind of look at it. I think there could be other interpretations, but that's how I look at it. So.
Excellent. Thank you, Mary. So we're coming up to time-ish, but I do have another question here that I'm hoping you will be able to give me your thoughts on. And as I've already said earlier in the event, if you have any questions yourselves from the audience, please do put them in the chat or let me know you want to ask. We do have some time still. But so how then do you, within a microservices architecture, how do you handle data consistency and your transactions and all of that kind of side of things?
Yeah, maybe I can start on that because I was working on the microprofile side for a solution. It's called the long-running actions. Because traditionally, if you say, because microservices have then their own database, or that's the idea. So people think, we are going to do distributed transactions, but that's based on logs. That means that it can go completely sideways if your system is not responsive or not working correctly. It also puts some coupling between your services, what we want to avoid in microservices. So the idea is that it's called the saga pattern, that you just have a commit as a normal commit, but yeah, the environment, the context remembers that there was a commit to that database, and then it goes to the second microservice and it can make its changes. If there is somewhere in the pipeline an error, then you need to roll back, and then that context remembers where it has been sending data to, and it asks for a compensation. So it performs that instead of an insert, you as a developer then need to implement a delete. That's then also that eventual consistency, because initially it was committed, it was there, the data was already available, but it can be that afterwards there can be a corrective action and then it's updated again or deleted, etc. So if you're interested in that, you can look up the saga pattern or microprofile LRA, the long running actions, to keep your data consistent at the end, eventual consistent.
Yeah, Rudy's all over this one, but he said it's exactly right. So essentially what the most common way to handle this is through the saga pattern that he mentioned. And yes, there's this new microprofile API. I don't think it's part of the microprofile core spec yet, but hopefully it's coming, that will help. But for now, eventual consistency and the saga pattern is what we do. So, we cannot have global transactions anymore because microservices are independent of each other. So, EJB's got a bad rap, but I really like the transaction handling of EJBs, and I miss it dearly nowadays. So what you do is microservice 1 commits a transaction, then microservice 2 commits, microservice 3, there's a problem, we cannot commit. Now you have to go back and undo what you did in microservices 2 and 1. So if you're implementing the saga pattern, you might have to code it yourself. long-running actions, or LRA, that Rudy was talking about, is it will take care of this, hopefully automatically, or at least for a lot less work on our part.
Yeah, for the moment, it's not automatic. As I mentioned,
Okay,
the developer needs to handle the event. Oh, it failed. Please undo this kind of action. So you as a developer need to do it. It's not automatically, but yeah, it's at least it is a way to have it a solution in that distributed world, which works nicely with the entire philosophy of microservices and the decoupled services.
Mm-hmm.
I think those things help, but at the end of the day, you mentioned the EJB. If you've ever had to debug an XA heuristic hazard on a production system that's locking half an Oracle table, then it's not magic. It can't do magic. If something fails and you try to roll back, and then the thing that tried to roll back fails, then you're often in trouble. I think the key bit is, the eventual and eventual consistency, which means that at some point in time it's inconsistent, which your services should be able to cope with inconsistency. If you expect it's an expected state of the system, and therefore it needs to be engineered into services that are concerned by that.
Mm-hmm. Actually, if you don't mind, a small question then for Rudy and David, since you both brought up the LRA, and if it's okay, right, real quick. So there's also orchestration and choreography in Saga pattern, right? So what would be, maybe just a quick kind of like guidance, right, on which patterns should like a microservices be using, right? Like for this kind of environment, should it be using the choreography Saga or using the orchestration one? Are there differences or something that we should be aware of between the two patterns, or is there still an issue in there? Not issue so much, but it's differences between the two approaches.
Yeah, for one of the two approaches, you need a central location where all the information is stored. But okay, I started a long-running action, a transaction, so you have an ID, and then you keep all the sub-IDs of all the changes that you've made. So either you do that in a centralized place, or you just keep that, for instance, in the header information of your request, and you propagate it from one system to another, so that that information is also distributed, and you don't need a central point, possible central point that can fail. So yeah, there are two options.
Okay, thank you. Okay.
Excellent. I love the conversation these events generate. I always find it really fascinating, because obviously I do have questions that I'm intending to ask, but I love that you've been popping them in the chat and things as we've gone along, everyone. So thank you for that. We are pretty much on time now, so all that is left for me to say at this point is thank you so much to Steve, Rudy, David and Mary for coming and sharing some of what you know and participating today. It's been really exciting to have you, so thank you to each of you. And thank you to everybody who has joined us as well, both here in the event, and if you're watching online now, then I hope you've found the event useful, and if you've got any further questions, do ping us a message and we'll see what we can do to get you in touch with who you need to chat with about that. We've got lots of comments coming in the chat as well saying thank you so much, really great event, thank you for your insight, great, good time. So so that's always really encouraging. So yeah, thank you so much to each of you for coming in and giving up your time to speak to us, and it's been great to see you all here, and I really look forward to seeing you at another LJC event very soon. Thank you, have a great afternoon, take care.
Thank you.
Thanks Abby for sharing.
Oh, you're welcome. You're welcome. Thank you, take care.
Thank you.
Thanks.
Bye.
Bye-bye.